So this is about the solar system. So looking inside, sort of kind of like general pictures. We have the panels on the ceiling of the cottage, which of course you can't see, but electricity from there comes into this thing, which is the charge controller. That is going to control how the panels charge the battery, which is over here. Then the battery charges is used to generate two things. One is the 24 volts for the fridge, which we'll come back to in a minute, and the 12 volts, which is for the lights and for everything else. In addition, we have over here, this is our latest addition, the inverter, which allows us to generate 110 volts to charge computers or run other devices that doesn't have 12 volt capability. So we'll talk about each of these individual here in a second. So this is the charge controller. You don't need to adjust anything on the charge controller, but the nice thing about it is it has a display, and the display allows you to know things like, for example, how much energy we're generating right now, how much we generated. This is today. We can go backwards and see a day before, what our battery voltage has been between 24 and 22 the other day. Anyway, it gives us a record of what's going on. There's really nothing for us to adjust on an everyday basis over here on the charge controller, but it's kind of like what's controlling everything going into our system. So this is the inverter, and the inverter basically converts DC voltage to AC. So it's hooked up directly to the battery by these big heavy cables back here, kind of like battery cables you'd see in your car. So the battery feeds it into here. It generates it into AC electricity, goes into a breaker here. This is the breaker for the AC power. Then it goes from here to the only plug we've got, which is over here for 110 volts. This is the only 110 volt we have. Normally it's off. You don't want to plug in our 10 volt lights in here. You'll blow the light bulbs. And this will only work when we actually have the inverter on. So back to the inverter and turning it on. Normally it's off. And the reason it's off is because even if it's on and not being used, it uses power. So there's a little button on top here that says on off. And to turn it on, we simply put the button down, hold it until the blue light flashes. And then the blue light is flashing, and now it's on. So our plug is now working. And we use it for as long as we want to use it, for an hour, a day, or whatever. And then when we're not using it, we're going to turn it off. And so again, we just got to push the button down, hold it down. It takes a while until we get a red light. There it is. We can let go, and that shuts the whole thing off, and it's not using any power. That's the inverter. So there are a series of breakers that we use to turn various parts of the system off and on. So if we come back in, here's the charge controller. In between the panels on the ceiling and the charge controller, there is a breaker. This one is PV for photovoltaic. And so this is going to be on all the time, except if we're turning things off or on to work on it. So that's the first breaker between the panels and the charge controller. And then from the charge controller to our battery, there's another breaker here, which is called battery. And again, if we were working on the battery, we might turn this one off. And it's simply a matter of flicking the switch down, that turns it off, and flicking it up again turns it back on again. Next to here is the breaker, which is coming after the battery, and it's got two sections. One is the fridge. So that's a 24 volt system, and it's going only to the fridge. And so that's off on. If we're using the fridge, we leave it on. And if we're not using the fridge, we turn it off. The other one here, which says all 12 volt, is in fact the lights in the cottage, 12 volt system. And again, if we were working on wiring for the lighting, we would turn that off or back on again when we need it again. So alongside this 12 volt system up here is in fact a meter, which tells us on the 12 volt system how much electricity we're using. You'll see now it says 0 amps and 12 volts. What that means is that at 0 amps, we're using nothing. That's a good thing. 12 volts means that in the 12 volt system, we have 12 volts available. In fact, it's usually a bit more. If the amps are greater than 0, I just turned a light on, and so it's reading 0.46 amps. That means that's how much energy we're drawing. The bigger the number, the more we're drawing. And if we're drawing amps and nothing is on, something is wrong. Usually it means somebody's left a light on somewhere. The bathroom is the most common one. And if we turn everything off, it goes back to 0. So continuing with the breakers, there is one more breaker, and the breaker is on the right-hand side over here. And so this is the breaker for the 110 volt system. Haven't used it yet. It's on all the time. It's not active if the inverter is off, but it's required to be there in case we overload the 110 volt system, and then it would blow, but hasn't happened yet. One last item on here are the fuses for the 12 volt system, and that's this little box down here. Currently we have 4 separate circuits on the 12 volt system, 2 for the living room, 1 for the kitchen, the shower, and the bath, and 1 for the red cabin. And so each of those separate things has a fuse inside here, which if we overload the system, the fuse will blow. And if the fuse does blow, there's one there, one there, one there, one there. We simply open the case, pull the fuse out, and put a fresh fuse back in. And there should be some spares in the shelf underneath the battery if that happens. So far, after a year, it hasn't happened, so maybe it'll never happen.